Hello friends, in previous lecture we had seen the various characteristics of wave. Now today we have the mathematical equation for progressive wave. Progressive wave means wave which is traveling. Now let us suppose uh, transfer wave is on the string traveling around x direction. Traveling around x direction. So before that, what do you mean by string? String is nothing but the flexible filament which is made of solid matter, and we can have the radius or length of the filament is more than that of the radius. So this is just a string. So we can have, this is the string which is a wave on a string which is traveling in x direction. Now here lambda be the wavelength of the the wave. A, B, C, these are the waves. Now this is x direction and this is y direction, this is x direction along which it propagating. Now each particle executes a simple harmonic motion, and uh, given by displacement, its displacement is given by y is equal to a sine omega t, a sine omega t. So omega t, say now where a be the amplitude, y be the displacement, and t be the time, and omega be the angular frequency. So considering omega is equal to 2 pi n, I can write a sine 2 pi n into t, a sine 2 pi into t. Now when a is at the mean position, b also in the mean position, c also in the mean position, so same state of vibration, they are at the same state of vibration, and therefore distance bc between these two is wavelength lambda, and we can have therefore a phase change is given here, a phase change is there, and therefore here if we consider 0, here pi, here twice pi. So while going from a to p, this is the p point, from a to p, the distance x from a, the phase is changed, and that will be given by phi is equal to twice pi upon lambda into x, which is the displacement. So this is about the when particle displacement x. So here y is equal to, in displacement of p is given by, y is equal to a sine omega t minus phi, because now it will displaced, the angle is introduced there, and therefore I will write then I will write here, I will erase, and now considering this equation, previous equation, then therefore y is equal to a sine twice pi n into t minus twice pi upon lambda into x. So putting the value of here, I will write this again, a sine omega t plus phi minus phi. This is previous equation, I will write twice. So a into we have sine twice pi into c upon lambda into t twice pi upon lambda into x. Here we have relation between frequency, velocity and wavelength, that is frequency, velocity and wavelength, and therefore this is used in this case. So therefore a into sine twice pi upon lambda getting outside, so ct minus x, if we taken this twice pi upon lambda outside the bracket, then we will have equation like this. So this is for y, and this equation is a general equation for the wave. This is the general equation for the wave, where I can write this is equal to a sine omega t minus kx, where twice 2 pi n, say 2 pi n, that is equal to omega, and we can write that is 2 pi n means I will write twice pi upon lambda into c, that is 2 pi n, and that is equal to omega. So here we have written here this omega here, and therefore k is propagation constant, which is given by twice pi upon lambda. K is propagation constant and x as it is. So I can have general equation or solution, exponential form, say more correctly, a e raised to minus I into the omega t minus kx, So this is the equation of wave, displacement of a wave in a positive x direction. If suppose this wave is in a negative x direction, that is the wave which is in a negative x direction, then the equation may be written as, only difference is that the sign minus becomes plus. So in the case of the wave which is traveling, which is propagating in a negative x direction, so y is equal to I will write final equation I into omega t, this is plus into kx. So this is the displacement of the wave in a negative x direction. So here we have completed this article.